Hello and welcome to another section in further maths. In this section, we'll be looking at the topic laws of algebra of logical statement. But before that, let us review the previous lesson. Okay, welcome back. Our lesson objective for today will be considering the laws that governs a logical statement. I would like us to name this as 1, 2, and 3. This is 1, 2, and 3. Now, the first law is trying to tell us associative law. Now, what we're trying to say, does it mean that they are both these two statements? These three statements are the same. Now, let's look let's use one example to justify our claim on associative law. Remember what we are dealing with? Associative law. And let's try this that says if P, Q, R, it implies P, Q, then the R will be outside. Let's see. If we are talking about a law like this, we are trying to see the relationship between the three points. Let's see how it goes. Let me say this is a table. Let's use this table. Divide it into 1, 2, 3, 4. We need to divide it into 8. 5. Wait, so it's 2. Now let's count. True, true, false, false, true, true, and the last line. We now have false and false. This is P. Then our Q becomes false, true, false, true, false, true, and false. Now, why this other one becomes an R becomes truth, 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 false, 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 false. Now let's do Q, the conjunction between Q and R. I told you in Q and R, it's only when they are both true that you have true. So let's have true, true here is true. Q and R is what we are considering. This is false. True, true here is true. False, 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 false. And now let's do the last part of it. Now we want to place the rule, want to check and see if it's associative. Now this last part will be for this. Now let's try it. Remember, this is this intersect this. So you now check this and this. This is P and this group. So truth, true is true. Truth, false, false. Remember, it's and. False, truth, false, false, truth, false, false, truth, false, 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 and false, false is false. So this is the value of this. Now let's prove this. Let's look for this. Using this same table, we want to create an arc for, let's divide it into 2 and create a side for P and Q. Remember, it's 8, 1, 2, 3, 4, 5, 6, and 7. Now let's create it. P and Q. This is P, this is Q. True is true. True false is false. False true is false. Remember, we only put true when you have truth and truth. False is false. That's number 4. True, this is true. Truth false, this is false. False truth, this is false. And false, this is false. This is for this. Then let's now create our answer, the answer that we are looking for. This exact stuff we are looking for. P, now this, and R. So we are looking at this table and this table. We only put truth when we have double truth. So the first one here is truth and truth. So put what here? Truth. So it's truth and false. We put false. The third is truth and false. We are having false here. Number 4 is truth and false. We are having false here. Number 5, 1, 2, 3, 4, 5. Number 5 is false and truth. We still have false. Number 6, 1, 2, 3, 4, 5. Then 6. Number 6 is false and false. Number 7 is false and false. And number 8 is false and false. So you can now see that this table is equivalent to this table. Look at it. True, then false, 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 and false, false. So associative law, then this is associative. So therefore your conclusion is P, Q, R, P, Q, R is what? Associative. Very neat. Then let's go into proving another law, which is the commutative law. I think this will just be a simple point for you to prove. Commutative law. The commutative law. Now the commutative law is just states that if P, Q, then Q, P. Now let's state if is true. Let's see if it is true. This for the first one. We have P here. We have Q here. Truth, truth, false, false. Truth, false, truth, false. Now this arc will be a segment for this. That is P and Q. Remember, it's only truth when they are both true. So let's go. True, truth is true. This is the only place. Truth, false, 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 truth, false, false, false is false. Now let's do for this. If that's the truth, Q, this is Q, this is P. Now I want us to check if it's the truth. Now this is for here. Now let's test it. Remember, our Q here is what? Truth, false, truth, false. Don't change the value. And our P originally is truth, truth, false, false. So let's check. Q in conjunction with P, we have, remember, it's only truth when you have both truths. So this is truth, T and T. FT is false, TF false, FF is false. So you've proven that there's a commutative law in this conjunction, that is P conjunction Q is equivalent to Q conjunction P. I think with this, thank you for joining us in this lesson. To refresh your memory on what we've just discussed, please take the test that will appear on your screen. Thank you.